Hello and welcome to this R tutorial. So in this tutorial we're not going to make any machine learning model, we're just going to make a template, and this will be our regression template. So it's a template that is going to be very useful for the next nonlinear regression models we're going to make, like the SVR model, the decision tree regression model, and the random forest regression model. So we're going to use this template to build these three next models on R. And also you can use this template to create a regression model for your specific problem, because as you can see, you will only have a few things to change so that you will build your machine learning model very efficiently. So let's make this template, and to make it, we're going to go from what we did in polynomial regression and generalize the whole thing. So I'm going to take everything from here up to the end, copy, and I'm going to paste that in the template. And now let's make this template. Okay, so first of all, let's start with the beginning. So the beginning was about pre-processing the data. So actually there is nothing to change here. We will keep, of course, these two lines because we will work on the position salary CSV file and build our nonlinear regression models on it. And for the same reason as before, we won't need to split the dataset into a training set and a test set because this is a small dataset. And we will leave feature scaling as comments here, since most of the libraries don't require us to apply feature scaling manually. So all good for the preprocessing phase, and this will be the first part of our regression template. Great, now let's move on to the next part. So the next part is about creating the model. Creating the model and fitting it to the dataset. So first of all, in the previous tutorial, we built two regression models, the linear regression model and the polynomial regression model, and that was just to compare the two results and to show you that the polynomial regression model was much more appropriate to our problem because it was a nonlinear regression model as opposed to the linear regression model, which is a linear model. So we only did that so that you can understand very clearly the distinction between linear models and nonlinear models. But now that it's getting pretty clear in our mind, we are going to get rid of this section here about linear regression because now we get the idea. And we will only focus on the new nonlinear regression models themselves without comparing them to the linear regression model, but keep the graphic results of the linear regression model in mind. Keep in mind that it was a straight line, not fitting very well the data set, and therefore was not much appropriate to our data set where the data is non-linearly distributed. Okay, so we're going to get rid of this. Done. Now we only have this code section here that creates the nonlinear regression model itself. So we're going to get rid of this because this corresponds to the polynomial regression, and to generalize we will just add a comment here to specify that this is where we have to create our regressor right here. Okay, and here we can also replace polynomial regression by the regression model, and we are all good with this section. Okay, now let's move on to the next one. The next one is about visualizing the results. So for the same reason as what we did in this section to fit the regression model to the dataset, we will get rid of the graphic results of the linear regression model because we have them in mind and we only want to focus on our future nonlinear regression models. So let's get rid of this, and now we only have the graphic results of our future nonlinear regression model. Okay, and the great thing about this template is that in this section we won't need to change anything, well, almost anything, because we're going to replace polynomial regression by regression model. And we're going to change this polyreg regressor here by regressor, because before we called it polyreg because we also had our linear regressor linreg, and so we needed to make the distinction. But now, since we got rid of the linear regression model, we will call our future nonlinear regression model regressor here, and that's why we input regressor here in the predict function. So basically, when we get to this section, when we build our future nonlinear regression model, the only thing that we will need to change is actually the title here. Basically, we don't have anything to change here. And that's the great thing about this template. However, of course, if you're using this template on your dataset and your problem, well, the only thing that you will need to change are the names here of the independent variable and also the name of the dependent variable here. That is, you'll have to replace salary by the name of your dependent variable. But that's all. Okay, and we're finally getting to the last section of this code template, which is about predicting the final result to get our final verdict. Okay, so same reason as before, we're going to get rid of the linear regression part for this. So here we go, goodbye. And now we're only left with the polynomial regression prediction. Okay, great. And so now we just need to change something here. Well, first it's the name of the regressor, because before the name of our polynomial regression regressor was called polyreg. And now, since we won't make the distinction between a linear regression model and our nonlinear regression model, well, our regressor will be called regressor. So here, regressor. And here, you know, for polynomial regression, we needed to input the polynomial features of our data frame that we created in our data frame. Well, we won't need to do this for the next nonlinear models, because this is strictly specific to the polynomial regression model, where, you know, we need to add those polynomial features. And so we will get rid of this and we'll get something very simple. It's actually this line that will perfectly predict the salary of this 6.5 position level. Because in our future nonlinear regression models, there won't be those polynomial features in the dataset, so we will only need the original independent variable here, and especially this 6.5 value of this independent variable. So that's why we have everything we need with this simple line. Okay, great. And now the last thing that I'm going to do is maybe to take this code section here, cut, and I'm actually going to place it between the creation of the model and the visualization, because I like to keep the best for the end. And for me, the best part, the most exciting part, is the part where we visualize our results. And for a second reason is that we know that our problem is a nonlinear problem, and that therefore we need a nonlinear regressor, and we're definitely already convinced of that. So that's why we don't need to execute this code section before this one to convince ourselves that we need indeed a nonlinear regression model. So therefore, for the next regression models, we will make the prediction before visualizing the results, and that's why I'm putting that here first. Okay, so I think the template is ready now. Well, maybe we need to change the polynomial here to generalize the template as much as possible. So we'll replace polynomial here by, well, actually, let's just put predicting a new result. All right. And here we can replace polynomial regression by regression model. All right. And now, just to finish this template, for those of you who are also interested in getting a smoother curve in your regression model results, well, there is this trick we can do to increase the resolution, and we're going to do that right now. So it's just an optional code section that I'm adding here in this template. I'm going to copy this because we will have just a few things to change. And, you know, for those of you who really want a very smooth curve when you visualize your regression model results, well, you can use the following code. So the trick is to actually create a new sequence of levels. That means that here, when we are predicting only 10 salaries of the 10 levels, well, what we're going to do now in this section is that instead of predicting only 10 salaries of 10 levels, we're going to predict a lot more than 10 levels. And to do that, we will build a vector of imaginary levels that will actually be levels from 1 to 10, incremented by 0.1. So that means I will consider level 1, level 1.1, 1.2, 1.3, up to 9.6, 9.7, 9.8, and 9.9. So that's what we will create in this sequence, and therefore here, instead of predicting only 10 salaries, we will predict actually 90 salaries of 90 levels. So that's the trick, and to build this sequence, it's actually very simple. We're going to call this sequence xgrid, because xgrid will replace dataset $level here and dataset here. And this xgrid is going to be defined as sec, which is a function that builds a sequence. And so in this function, we need to input 3 parameters, the lower bound of your sequence. So that's actually min dataset level, because by doing this, we're taking the minimum of all the levels in your original data set. All right. Then the next parameter is the upper bound of your levels. That is level 10. And therefore, we do the same with the max here. Max dataset $level. All right. And the third parameter is the step. So that's where we increase the resolution and make our fitting curve smoother, because here we're going to take a step of 0.1. And therefore 90 levels will be created here from 1 to 10 incremented by 0.1. All right, so that's actually done. And now we need to replace dataset $level here that originally took the 10 levels of our data set. So we are replacing that by xgrid. And same here, we need to replace dataset here by a new data frame, because this new data argument here is expecting a data frame here. So we cannot replace it directly by xgrid here, because xgrid is not a data frame, it's a sequence. That is, it's a vector. So what we need to do here is use this little trick again, but don't worry, it's quite simple. We need to use this data frame, data.frame command here that will actually create a data frame. And in parentheses, we're going to specify that we want to create a data frame of new levels. So I'm taking the variable level here, and then equals, and that's where you put xgrid. Because by doing this, data frame level equals xgrid, we're just creating a new column of levels containing all the levels in this sequence xgrid here of levels. And that's it. This new code section is ready to plot your regression model results in a higher resolution. And actually, we're going to specify here that it's for higher resolution and smoother curve. All right, and that's actually ready. So you can try it on either, your polynomial regression model that we made in this section, or you can use it on the future nonlinear regression models that we're about to build, and you will see the difference between these two. But then if you want a more simple code, you can use this one. Or if you have, for example, a data set with 100 observations incremented by 1, then this is the code you need to execute, because then you wouldn't need a 0.1 step to build your different points of your fitting curve. All right, so now the template is ready. We're actually ready to use it for the next nonlinear regression models that we're about to build. We will do that in the next sections, and you're going to see how we will be so efficient at building them. So I look forward to creating these models with you. It's going to be very fun, and we will make them in the most efficient way.